Hello everyone, and welcome to this presentation on chemical bonds. The purpose of this video is to hopefully help you gain an understanding of the different types of chemical bonds and what sets them apart from each other. Chemical bonds are essentially attractions between either atoms or molecules, whereby the atoms transfer or share the electrons in their outer shell with one another. The first type of bond we're going to talk about are ionic bonds. Now, before we can really get into that, we have to know what an ion is. Atoms are naturally neutral, meaning that for every positive proton, there's a negative electron to balance it out. However, when an atom gains an electron or gives one away, it becomes unbalanced, which imparts a charge. The atom is now considered an ion. Okay, for this example, we're going to go ahead and pretend that each valence shell in the atom is a set of trading cards. The first shell, or set, only needs 2 cards to be complete, while the second shell needs 8 cards to be complete. Our friend fluorine here has a complete first set of cards and now only needs 1 more card to finish the second set. He would be happy and content with that last card since it would complete his set. Now in walks the new kid, which we'll call lithium. And lithium is new to the card collecting scene because he only has his first set that are full. But he does have a single card to start a second set, which just so happens to be the card that fluorine needs. Now lithium wants to be friends with fluorine, so he goes ahead and gives him that single card so that his set is full. Now this is fine with lithium because he still has a complete first set. So even though he's giving away a card, he wasn't anywhere near to finishing that second set, so it's okay with him. But lithium does still want to collect cards. He still wants a complete second shell, so he takes on a positive charge. Fluorine, on the other hand, now has a complete second set and is no longer actively seeking any more cards, so he takes on a negative charge. But just like magnets, even though they're oppositely charged, they decide to hang out with each other based on their interests, which in this case is their exchanging of electrons. Okay, for this example, we're going to use 2 atoms of hydrogen. As we can see from the atomic number, hydrogen has 1 electron, which would mean that it also has 1 opening in its first valence shell. The same is true for the other hydrogen. Now, why wouldn't these 2 atoms simply perform an ionic bond like we saw previously? Well, if we go back to our trading card analogy, there wouldn't be any reason for this hydrogen to give up his 1 card to this hydrogen because he's so close to completing his first set. And the same is true for this one. So instead, they're going to share, as we can see here, their cards together so they both have a complete set, as opposed to one of them having a complete one and the other one being out completely and not having anything. So when they come together, they look like such. So now, because neither one of them gained or lost any cards or electrons, they're simply sharing them, so they would remain neutral and thus are not ions. Another type of covalent bond is the polar covalent bond. A polar covalent bond is a bond between 2 nonmetals with different electrical charges. Only bonds between the same elements are truly nonpolar, as we saw with the 2 hydrogen atoms previously. The higher the difference in the electrical charges, the more polar the bond is. I like to think of it in terms of planets and moons. The larger planet, which in this case is the oxygen, will have a stronger pull on the smaller moon, which in this case is hydrogen. So the electrons circling the nucleus of the smaller hydrogen atom will tend to stay closer to the pull of the larger oxygen atom. This in turn creates a slightly positive charge on the far end of the hydrogen atom and a slightly negative charge on the far end of the oxygen atom. Now when another water molecule comes by, the slightly positive end of its hydrogen atom will be attracted to the slightly negative end of the molecule's oxygen atom. Finally, we're going to talk about hydrogen bonds. A hydrogen bond is the attraction of a slightly positive hydrogen atom to a different atom that has a slightly negative charge, which in this case will be the oxygen. So here we have the slightly positive end of the hydrogen atom and a slightly negative end of the oxygen atom. This space in here is the hydrogen bond. Now the term hydrogen bond is not entirely accurate, since the atoms aren't sharing or exchanging any electrons, so they're not truly bonded together as is the case with ionic and covalent bonds. Instead, they're attracted together by the magnetic pull of their polar ends, much like a magnet. This type of weak bond is the reason we're able to reach into a pool and remove a handful of water without having to put a large amount of energy into it like we would in order to break the bonds between ionic and covalent molecules.